I've got the same outlier, at least one of them.
Oh, good. So we see this, there's this interesting dude over here that we may want to revisit, and we can tell by the modified box plot he is truly unusual, at least by that method. Good, good. So they're similar in that we, go ahead, keep going.
And then we have the same grouped numbers.
Nice. So whether you guys use a distance of 5 or 4 or 3 or 2, you still have, if you will, a bit of a mound shape.
But they're all together.
You've got that kind of modal center. Very, very good.
And what I'll also notice that practically our box on top of it, it covers the left border and
Good.
some numbers in the
And this is why I love having a box plot on top of a histogram. Because the box, what does the box show again, friends? The middle 50%, exactly, Trev. So when you drop that down on the histogram, you'll say, oh look, that's where the lion's share of the data is clustered.
And it's got also median, it's average.
Yep.
It's average.
The median is essentially, no, your median is, I calculated it. Well, the TI did.
Yeah.
And the median and the average are both 69. So I'm stoked with that. So yeah, that's how they're basically the same. Some folks will say they're different, because if you graph it with zoom 9, it looks like it goes kind of exponential and there's a squiggly point out there. You can call that different. You can say, how many of you said in question number 3, it was appropriate to use the 2 standard deviations rule because the data looks bell-shaped enough? Yeah, go ahead, be brave. I would have too. How many of you said no, it's not bell-shaped enough? That's okay too. That's okay too, because you can look at that and go, you know, I don't think it is. Even though Pearson says it's essentially 0 skew, I still think it's leaning too far to the left to be considered normal. That's totally fine. That's why we have the other method of outlier calculation, to kind of look at it that way. Totally fine. So, as you're running your values, which values came up as outliers using 2 standard deviations? Which data values came up as outliers using 2 standard deviations? 81, that's too fast.
And 56.
And 56 is too slow. Very, very good. Very, very, very good. So I'm gonna calculate real quick here. Hang on. I'm just gonna back up right quick. There's that. There we go. Here's that. So there you go. Oh, Haley, I got you. So what you're saying is 81 would be the maximum typical speed.
Yeah, sorry.
56.15 the minimum typical speed.
Yeah.
So were any of the actual data points outliers by that?
86.
We got 56, just barely good. And what was the other one, Jen? 86.
But
So go ahead, Haley.
Would 56 be considered?
Your call.
Okay.
Haley's concerned, and this is a valid concern, because 56.15 rounds to 56. And one of your data points was 56. So if you guys say 56 is an outlier, cool, because technically, mathematically, with all this precision, it is. If you say 56 is not an outlier, because if you accept the same precision from this number that we really should from the raw data, that's cool too. Is there any doubt that 86 is an outlier? Is there any doubt that 86 is an outlier? Is there any doubt that 86 is larger than this? I don't think so. It's 5 miles an hour greater than 81, even if you round it down to 81. So yeah, I would say there's definitely at least one outlier at 86 miles per hour. And as David said, he used to live next to the 405, and he can't believe it was going that fast down there. So that's definitely an outlier. But 56 is not considered to be too small. There's enough low values clustered down around there. So your choice on whether you want to put 56 as an outlier or not. Totally your choice. Totally your choice. Notice only one shows up in the modified box plot as an outlier, doesn't it? Only the 86.
Yeah.
That's okay. Go ahead, Haley.
Well, let's see. Hold on.
What are you doing? Tell me what you're
Well, I
doing.
just wanted to see it like if there was 2 outliers, so I added like a 54.
Oh, good. And did that pop out?
No.
Now, you got to remember, Haley brings up a good point. She threw another data, she wants to see another outlier. So she tried to create another outlier by throwing a 54 in there. You got to remember, when you add a new data point, everything gets recalculated.
Oh,
So
right.
54
really...
might not be far enough away. The whole thing's going to pull down towards that. Make it exaggerate, like a 12 or something like that. Yeah, throw like a ridiculous value in there. I'll just insert it in the top here. Call it 12. Zoom 9. Whoops. Zoom 9. There it is. Make the window a little more logical.
And then do your minus
There. So there's your second outlier. It wreaks havoc on the rest of the graph, doesn't it? So now you've got this goofy outlier down here left and this goofy outlier up here right, but that goofy outlier right looks now closer to the data than it did originally, which it should be, because it is. 86 is not as far away from 81 as 12 is from whatever it was, 56 or whatever. Make sense, Haley?
Yeah.
Good. I got a question for you guys now. I want to take that superfluous data point back out. Why do you think we care about this data? Why do you think, say for example, police would use this data? Why do we care? Say that again. And what particular crime are we speaking of?
Robbery.
Is there a correlation between speeding and robbery? Maybe. If I'm not aware of it, if there is. Driving very fast to get away from somewhere.
Carjacking.
Carjacking, perhaps. But more general. Speeding.
Yeah.
Are these cars speeding? Here's a loaded question for you to ponder. Are these cars speeding? Now, I'm speaking on average. What do you think? Speed limit on this stretch of highway, 65 miles an hour. How would you, if you were a traffic control officer and you had to decide, should I be putting police officers out on this stretch of highway, would you bump up the patrols? Ryan's saying no. Tell me why, my friend.
It's not much over the average.
So Ryan's saying, look, the average is 69 miles an hour, the median 69 miles an hour. That is 4 miles an hour over average. And everybody knows cops give you 5 to 10 over speed limit. I don't know if that's true or not. I keep being told
Probably
that.
not 10.
I ride a bike, so I don't, probably not 10. 9.9.
Yeah.
So 69 miles an hour is not far enough above 65 to be considered speed. Okay, I'll buy that. That's a good argument. Who agrees? Who seconds that? Who seconds that? We got a second and a third and a fourth and a fifth. So there's one. Mimi's saying, no, I don't like that
Oh,
argument.
no, I was
Oh, what's the matter? What are you lost on?
We are just having trouble with our computer.
Oh, in the graphical part?
Yeah, it's like.
Let's take a quick look. There you go. Zoom 9 gets you back to always Zoom 9 if you get stuck. So, can I offer another way of looking at this? Instead of looking at the graph, well, you know what the hell? Look at the graph. Let me find 65. Hang on. We got window 56 by 3s. So we got 56, 59, 62, 65. There's 65. Okay, right?
We have way more than our more than 6.
That's average. Or excuse me, that's the speed limit. That's the speed limit. So here's a way to think about this data. What Haley just said is the way I would kind of think about it. Sure, the average itself, the 69, is not that far over average, but if you put 65 miles an hour right there, right, how many cars are actually close to that? Define close as you will. But here's the first thing I noticed. Plus that, but you see where that 65 goes up? It's not perfect, but it's essentially Q1, correct?
Mm-hmm.
What does that mean? If it's essentially Q1,
25% are driving less than that.
which means that
75% are driving more.
75% are going, and if you will, because no one's looking at it, the typical 50% are all exceeding it.
Right.
You see? I'm not saying this is the way the police are going to interpret this data, but I'm saying that's how I would look at it. I'd be like, okay, we can say it 2 different ways. Ryan, the average speed by these cars is essentially 65 miles an hour plus 4 miles an hour, not that big of a deal, right? I look at it that way and I say, holy hell, 65 miles an hour is the speed limit, 75% of the cars are exceeding it. Even if I take the outlier out, and we'll come back to if we should do that or not in a minute. But even looking at it that way, the typical middle 50% are all going over that 65 miles an hour. That gets hidden a little bit with the X bar plus or minus 2s, doesn't it? What were the ranges on the X bar plus or minus 2s, friends?
It was the 81 and 56.
So 56 to 81, that you lose the 65. It's in that range. So you might say, well, 65 is in the range, therefore they're obeying the speed limit. That's why I kind of like looking at it in 2 different ways. So X bar plus or minus 2s is going to do this. But this is another way of looking at it. And I'm not saying there's one right answer to that question. I'm saying there's a couple different ways of looking at it. So, yeah? Is that ish? So what do we do with that outlier? What do we do with outliers? Why do we care about them? Why do we care? In this case, why do we care about them? David, you proved the point, actually. Say that again?
Said they throw off our data.
They, in what way? They throw off our data.
In the, yeah,
They leave us
balance.
unbalanced.
And what measure defines balance?
Median.
Careful, balance. That's geographic center.
Oh, mean.
Mean.
Average.
Good, good. So I'm going to swing the camera over to the side here. I want to make a little bit of a laundry list as to why we care about outliers. Why we care about them, okay? This is why. Your textbook has no section on outliers. I think that's a crime. Because in outliers are the only reason Math 244 exists. How many of you have ever taken ibuprofen for pain? The reason you take ibuprofen for pain is because the controlled statistical studies were done that showed ibuprofen does a better job at relieving pain than placebo. Which means the results from ibuprofen were outliers when compared to placebo. Anytime you take a drug that's FDA approved, it passes a double-blind, statistically controlled, thousands, if not tens of thousands of trials, drug tests that shows that it actually is doing what it's supposed to do. You ever seen drugs have side effects? Those side effects also are found as outliers from placebo. All this 244 exists because of outliers. And when your textbook doesn't have a section, I'm like, well, I'm getting upset here. I'm upset. So we create this section. So why do we care about them? First of all, boom. We care. Why care about outliers? Why indeed? Why do we care about outliers? Okay, number one, the presence of outliers can negatively impact certain statistics, i.e. the mean and standard deviation. So the presence of these atypical data values it can skew or pull your X bar and or your S. So Robin, I love that you said balance. That makes me so happy. Because they create imbalance. But balance is all about the mean. Does the median care? The median doesn't care. The median's not going to move. The median in this data set is not going to change if that 86 miles an hour becomes an 81 miles an hour. The average will. The average will get smaller. But the median won't change one bit. All it knows is it's the biggest. No, you guys got it. You guys got it. Unbalanced. That keyword unbalanced makes me so happy. So happy. So David noticed it right away. He said, wait a minute. I live down at near the 405. And I can't believe somebody went 86 on the 405. So what did you start doing right then, David?
I was trying to think of what time of day they would have done it.
The presence of an outlier can also indicate, yes, an inconsistency or an informality or some other difference in how a data point was measured compared to the rest. So it might, I'm going to put might above this. It might indicate inconsistent data sampling. I put might. Maybe that one data point of 86 miles an hour was a motorcycle that was clocked at 3 a.m. And all the other 39 points were cars tracked during rush hour or at 5 in the morning, who knows what. But that's what I'm saying. It might not, it might. It might give you reason to go back and look at that data point and say, should this data point even be in this group of other non-related data points? Give you a perfect example of this. Back in the late 70s, early 80s, station wagons, which now everybody calls SUVs. Station wagons, there was a fuel economy test done on station wagons. And there was one, the Buick Estate Wagon. This is back when they had wood paneling on the sides. Totally sexy. And this one Buick Estate Wagon, same size engine as all the other ones, same wheelbase, same weight, pretty much the same car as the Ford, as the Chevy, as the Lincoln, whoever else. The Buick Estate Wagon was getting significantly higher miles per gallon than all the other similarly built cars. And they couldn't figure out what the hell's going on. Why is this car, which is essentially the same car, why is it getting 5, 6, 10 miles an hour more? The recommended tire inflation on that car in the manual was significantly higher. So it had less rolling resistance. So it was using less gas, which means it got better mileage. But that was an inconsistency in the measurement, right? That's the 86 mile an hour motorcycle at 3 a.m. versus the minivan full of soccer team at 8 p.m. That's the difference. And they went back and found that and said, oh, if we adjust for that data point to make it like the other ones, oh, look, it falls right in line with everybody else. So it can show, you can find that inconsistency in measurement. But here's my favorite. This is my favorite, and this is where 244 comes in. It might indicate a whole new population. It might indicate a whole new population, which means, although you've got a data set in front of you that's got a bunch of numbers in it, it might be that a big chunk of those numbers belong together and one or two or three of them belong somewhere else. And this is my favorite example. Let me share this with you. This is just because it hits close to home. What's that? No, but similar. My son on his bike. My son on his bike. So, it is. So what I did, and if you have kids that have learned to ride a bike, you know how important this day is. I mean, it was pretty amazing. And I'm a biker. I bike everywhere. So seeing my son ride a bike for the first time was pretty tear-inducing. Clear some. Yeah, I still watch. I made a video of it, and we watch it together sometimes. Look at me ride my bike, and I'm like, I know. He rode a bike at 46 months of age. Wasn't even 4 years old.
Wow.
Right? His friend Hazel, 44 months of age. Owen, 48 months of age. Peyton, 45 months of age. Sean, 60 months of age, 5 years. He wasn't even 4. Took me till I was 5. I would be an outlier compared to all of his friends. So if you look at all those months together, 45, 44, 46, 48, whatever they were, 60, I'm way out here compared to them. So I'm an outlier by any measure that you look at. So was the data measured inconsistently? No, because I asked my mom and my dad, and they both remember being about 5 years old, and they're divorced when I was 5, so that was 2 different members of the same thing. So I'm like, okay, I can trust that. Atypical can pull average, sure. So I want to look at that outlier of 60 and say, what the hell caused it? So I started looking into it more and more. Why do you think? And I started asking my sister. My sister also rode a bike much later. My friends, my age, also rode a bike much later. But all of us that are having kids now, a lot of our kids, in Bend at least, are riding bikes much earlier. What's going on?
Where you grew up?
Why? What happens with kids when they learn how to ride a bike in this town? This might be a very loaded question for those who don't have kids. Their parents can push it, that's one. That's one, because I encourage it. I'm out there every day riding my bike with him.
Yeah.
We've got mountains and people do it very often.
Oh, gotcha. Although this was pretty much in our neighborhood, but you're right, it's more of an inspiration to do it. I'm thinking something more concrete, and I might be too specific.
It's more environmentally sound.
You guys do big pictures, way big pictures, which is fantastic. I love this, by the way. You ever seen what's called a scoot bike? You ever seen these things?
A balance bike?
Balance bike.
Yes.
Wow.
We all got our kids. They make these things called scoot bikes, little wooden bikes without pedals. So basically, it's 2 wheels, handlebars, and the kids run on them.
Yeah.
And what happens? They develop their sense of balance while they're doing that versus slapping training wheels. He never used training wheels.
Yeah.
I use training wheels. Chances are all of us did.
Yep.
But training wheels are artificial balance. You never work on balance with them because you're constantly leaning on the wheels from one side or the other. All of his friends grew up on these scoot bikes. All I did was I got a Fisher Price one from a pawn shop and chopped the pedals off. Go off, Max. $5. Scoot bikes are expensive, like $100 a pop. They're gorgeous, made out of solid wood.
Yeah,
But I was like, or we just chop this off and go, little man. And there he went. So what you're doing is, yes, definitely, I think what you guys are saying is 100% correct in that we're inspiring him, we're pushing him to do it and things like that.
Think about those.
You wouldn't because it's so subtle, but everybody out here, at least the ones that I queued for data for this, use them. But none of our generation did.
Were they even there?
Probably not. Training wheels, that was the order of the day. They still sell training wheels at the bike shops.
Yeah.
But these scoot bikes, as far as this
They're
goes,
awesome.
what I'm essentially seeing, if you think about it graphically, so you're seeing time of first ride without pedals. So you got Max and his friends down here, and I'm way over here. So I'm an outlier. It took me longer. So here's your average of, say, 45 months. Okay, 45 months. Here's me at 60. So yeah, it could just be that I'm a goofy element of this curve, but it's also more likely that I'm a part of some other curve that's old codgers that learned how to ride their bikes in the 70s. You're right, you see what I'm getting at here? So that's the whole point, is that outliers can sometimes point to you like, hey, maybe you're looking at two separate, and this is 244. This is 244. Here's your placebo. Here's your experimental group. All of a sudden you're like, wait a minute, maybe we're not looking at the same thing. Maybe it actually is doing better than placebo. We have Advil. We have whatever else. We have Lipitor. We have Advil. We have, what's the one, the fizzy one, for allergies and colds? Airborne. We have Airborne. Well, that study was a piece of crap. But that's a poor use of the statistic. That was trying to imply this when it actually wasn't there at all. But nonetheless, that's what these studies are doing. They're trying to show you if you actually have more than one or two results.
So it's like with every graph, every data.
Good.
It's kind of like you got to look at different aspects of you look at the outliers, so you're like, okay, why is that an outlier?
See, Haley, I love this. You look at the outlier and you say, why? Why is it out there?
Is it just because of the numbers, or is it because of
And that's what makes statistics so interesting. Very often, stats is used to prove things. Prove things, right? Prove things. No, stats helps us uncover things. It says us, why did it take me 60 months when it took Max 45? Why? What underlying thing is happening? Yes. And that's why I couldn't let this go without a section. I needed to have a section with it, because this is, like I said, the basis of 244. It's going to be the basis of deciding a whole bunch of things as we go through, from my chicken flock to the way Max wears his Crocs to all kinds of other things, to how many kids can ride a ride at Disney World. I mean, there's all these great data sets that have been collected over the past few years that show us all this stuff. And I wanted to bring up one today to end up with, because it was just in the news recently. Did you guys, the Amanda Knox thing, which apparently happened years ago?
Yeah.
They're going back to court now.
And here we have double jeopardy. They don't have it in Italy.
Exactly, because of a challenged DNA result. So Amanda Knox, get me caught up, Robin, because I'm going to say it wrong. What happened again?
oh my goodness.
A suspected murder, correct?
Right, of her roommate.
You tell us the story. While you're telling the story, I want everybody take a penny.
She got off.
Okay, everybody take a penny.
She came home, and then they said that the DA made a mistake and that they needed to reevaluate
The DNA
case
results,
again. Yeah.
I believe. Okay, good. Go ahead. Keep going.
So it was a murder in Italy?
Apparently, she was an American living in Italy with a Italian boyfriend roommate, I believe, and I think a drifter roommate as well.
Yeah. Gosh, I really don't know about
And the roommate got killed.
Yeah, the roommate was murdered, and at first it was Amanda Knox and her boyfriend on trial.
Okay.
But they let him go, and she stayed.
Okay. And basically, they collected forensic evidence.
Yes.
Came to a result about this. What's interesting about this is I just got an article sent to me yesterday involving the coin that's sitting in front of you. Involving the coin that's sitting in front of you. Before I get in too far into this, because we're going to collect some new data here. Are we okay with this in-class quiz? Everybody's happy with their results?
Oh yeah.
So we got ourselves a histogram. They're all going to look slightly different. They're all slightly different. Let's make a pile up here on the top here. Just hand them forward. We'll make a little pile. Get them back to you guys on. So we know we're pretty certain that 86 is an outlier, a valid outlier. Mm-hmm. And we're pretty sure that 56 may or may not be, depending on if you want to call it one. Mm-hmm. And then we like the modified box plot, kind of agrees with that. It says 86 is too big, 56 is just fine. Love that. Thank you, Mimi. Beautiful. So, good. That's basically, those are the two computational methods of finding outliers. Haley, I think, hit the nail on the head, though, when she said, okay, once you know they're there, what does it mean? And that's kind of where we get into this. That's why we care about them. Because they can mean a number of, they can mean more than that too, but those are the three biggies right now. So what I want to do is, I want to drive home the point from this article that I just read. I want you guys to each take that coin, flip it 10 times, and keep track of the sequence of what you get. Okay? So write down H's and T's for heads and tails. I'm going to go ahead and shut this down for a moment.